Hey kiddos! It's 4:21. Guess who's still at school? Not that I don't love school, I do, but kind of wish I was in Hawaii with Carl the Lady Hamster right now. Carl, save me! Okay guys, so here's the thing. I gave two different messages to two different classes today. Module 4 has been a little tough. Sometimes the beginning of a module is awkward because we're doing a lot of exploration and a lot of creative thinking, and we're not doing anything traditionally or algorithmically, which is okay. And I know that I said I was going to stretch lesson 3 across 2 days. I've changed my mind. It's totally unnecessary. Lesson 4, we're still interpreting division. We're thinking about what that means. We're being very mindful of it, and we're taking a look at division in a few different ways. So you guys can totally handle it. I know the lesson today was a little murky and strange, but just continue connecting division to what the expression can look like in fractions. Right now we're going to look at division as tape diagrams, and we're going to do some long division, and we're just still investigating exactly what division means. As you guys know, we're going to be leaning into traditional algorithms soon, but we are just going to take a little bit more time to really investigate what division means so that we have a very solid foundation of the operation and we're not just mindlessly calculating expressions. So here goes nothing. Okay, kiddos, so we are in lesson 4. Our learning target in lesson 4 is to continue interpreting division. Now what we're going to do is we're going to start connecting these expressions to a tape diagram. So 2 divided by 3, you guys know by this point in our learning that 2 divided by 3 is the same as 2/3. What we're going to do is we're going to draw a tape diagram. It's very simplistic. Our tape diagram is going to represent 2 whole units. We're going to divide that tape diagram into 3 equal pieces. And then we need to figure out, what does this unit represent? Okay, so here's what we know. We know that 3 units, 3 units equal 2. So my question to you is, 1 unit equals what? 1 unit equals, well, 1 unit equals 2 divided by 3, or 2/3. Let's go ahead and prove that. We are going to check that out using long division. We're going to look at 2 divided by 3. Well, how many 3's go into 2? Can't do it, but we're going to continue our long division. 0 times 3 is 0. We're going to subtract. 2 minus 0 is 2. So our answer here is 0 and 2/3. Interesting. So 2 divided by 3 is equal to 2/3. Wow, cool. Okay. Let's check. So according to our long division here, we are going to do 3 times our answer, 2/3. We're not multiplying fractions yet. We know that multiplication is repeated addition, so we're just going to add up 3 sets of 2/3, and let's see what we get. 2/3 plus 2/3 plus 2/3 is equal to 6/3. 6/3 is equal to 6 divided by 3. 6 divided by 3 is equal to 2. Okay, cool. Okay, so we're going to do the same thing. Let's just look at D here. So we're looking at 14 divided by 5. You guys know that 14 divided by 5 is the same as 14 fifths. And now what we're going to do is we're going to use a tape diagram, a very simple tape diagram, to model 14 fifths as division. So our whole tape diagram represents 14 because that's the number that we are dividing. Our whole tape diagram represents 14, and then we're going to slice 14 into 5 equal pieces. 14 divided by 5. Okay. So we want to figure out, what does one piece equal? Here's what we know. We know that 5 units, 1, 2, 3, 4, 5, 5 units are equal to 14. So 1 unit is equal to 14 fifths, or 14 divided by 5. Let's further investigate this fact with long division. So we're going to divide 14 by 5 and see what's happening. What we're doing here, you guys, is actually a mathematical proof. We're proving that this works. This is pretty advanced stuff for 5th grade. So how many 5s go into 14? 2 with some left over. 2 times 5 is 10. We're going to take 10 away from 14 and we're left with 4. 4 fifths. Okay, so that's our final quotient. Let's check that using multiplication. So if this were to work, we would have to take 2 and 4 fifths and multiply that by 5. You guys know that multiplication is repeated addition, so what we're actually going to do is add 2 and 4 fifths 5 times. Here goes nothing. That's 3, 4, 5. Let's add our whole numbers first. So we have 2, 4, 6, 8, 10. Sorry, I got sidetracked. So that's 10, and then let's add our fourths. So we have 1, 2, 3, 4, 5 copies of 4, which is 20. 5 copies of 4 are 20 fifths. That is an improper fraction. Let's simplify that a little bit. We have 10, sorry I'm down here at the border, plus, let's simplify 20 fifths. We know a fancy way to rename whole number 1 in fifths language is 5 fifths. So how many 5 fifths can we pull out of 20 fifths? Interesting. I feel like I have... we can pull 4 sets of 5 fifths out of 20 fifths. So let's do that. That's 3 sets of 5 fifths and 4 sets of 5 fifths. So we've just renamed 20 fifths. We're simplifying 10 and 20 fifths because this is a mixed number with a really improper fraction. We've just decomposed 20 fifths into 5 fifths plus 5 fifths plus 5 fifths plus 5 fifths. You guys know that 5 fifths is equal to 1. 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 So let's add up those whole numbers. So we have 10 plus 1 plus 1 plus 1 plus 1 is equal to 14. Remember, this is our check. So this should be the number, the same number as we found in here. Bingo, it checks out. As it turns out, 14 divided by 5 is equal to 14 fifths. Very, very cool. Okay, kiddos, here is another table. We saw a table today in lesson 3, but we're not going to be afraid of this table because it's all information that we are capable of arriving at. right, so division expression 13 divided by 3. Yes, we know the fraction version of that is 13 over 3, and we're not quite sure of this yet, but we will be very sure of that after we do the traditional algorithm of 13 divided by 3. 4 and 1/3, yeah, so do this column last. 4 and 1/3, between which two whole numbers is your answer? Well, 4 and 1/3 shows up between 4 and 5. Just think about where that is on your number line. Okay, so let's try, and we don't even have to fill in all of the information here. So let's try 1 down. Oh, these are all good. Okay, let's try this one. This one looks fun. Okay, so we have 32 over 40. You guys, in your infinite knowledge, know that 32 over 40 can be rewritten as a division expression. That would be 32 divided by 40. Okay, so now we just have to use the traditional algorithm to divide 32 by 40. How many 40s go into 32? Well, no, can't do it. 0 times 40 is 0. 32 minus 0 is 32. Come on, little pen. So our quotient here is 32 40ths. And for this table, we don't even have to check that. We'll just make sure that 32 40ths is what you got over here. And then this column, we can't see the heading, but this column asks, between which two numbers does 32 40ths occur? Think about 32 40ths on the number line. And you guys know that 32 is less than 40. So 32 is not yet 1, but it's certainly larger than 0. So 32 40ths will show up on the number line between 0 and 1. It's not quite a whole number. So you guys can handle this table.